Hello, welcome to the short lectures in physics. And today's topic for discussion is projectile motion. When a body is thrown into air and is made to travel under the force due to gravitational attraction, so that motion of the body is known as projectile motion, and the body is called a projectile. So, in the process, the body moves both in horizontal direction as well as vertical direction, that is in the x direction and the y direction. Hence, it can be treated as a planar motion type of motion taking place in a plane. Examples are a cricket ball thrown in any direction, and bullet fired from a gun, and athletes making a high jump, and a body dropped from a moving train or vehicle, etc. So the so consider a body projected from the point O, that is origin, at an angle theta with the horizontal. The angle theta is called the angle of projection, and it will have two components in the horizontal direction, that is x-axis and y-axis. The horizontal component is u naught cos theta, because theta is the angle making with the horizontal, and u naught sin theta in the vertical direction at the initial condition, that is when time is 0. So it may be noted that the horizontal component, that is ux is equal to u naught cos theta, remains constant throughout its, but the vertical component keeps changing under the influence of gravitational force of the earth. In other words, the motion can be said to be taking place in the horizontal direction with a constant velocity, there is no acceleration, but in the vertical direction it is a constant acceleration g in the vertical direction. So constant velocity in the horizontal direction and constant acceleration in the vertical direction. The body motion can be considered like that. So in this slide you can see the various terms which are handy for us for discussing the projectile motion. So the projectile, once thrown from the force to a maximum height at the point U as shown in this slide, and then it falls back to the ground and touches the ground at the point Q. So the distance traveled in the horizontal direction, that is the distance between the points O and Q, OQ, is called the range of the projectile, and the path taken by the projectile OUX is known as trajectory of the body, and the maximum height VU is called the maximum height reached by the body. So these are the three terms, and also the time taken by the projectile to travel from starting point to end point is the time of flight, T, capital T. So let us find out the motion and in the x direction and y direction, so that we will get mathematical equations for the range and maximum height. So if you see the initial conditions of the body at the point O, the coordinates are x is equal to 0, y is equal to 0, both position coordinates. So at any other point like S at a time small t, its coordinates, let us say x, y. So at the time small t is equal to capital T, that is time of flight, its coordinates becomes x is equal to r and y is equal to 0. And at the maximum height position, that is point u, x is equal to half the range, that is r by 2, and y is h max, that is maximum height. So now we can find out equations for respect to terms. So its motion along the x-axis, because we know the velocity is u naught cos theta, and time, any time t is known. So the x direction, the distance moved in the x direction by the body is u naught cos theta into t, which is obtained from the standard linear equation motions x0 ut plus half at square. That is the general equation. So here x naught is the initial position, which is 0 in the present case, ux naught is the constant velocity u cos theta, and ax is 0 because the body is moving in the constant velocity. There is no acceleration in the x direction. So ax is 0, x naught is 0. So it becomes u naught cos theta t. So that the range becomes u naught cos theta t, small t is replaced by capital T, the time of flight. So range is given by u naught cos theta into its time of flight, that is. Similarly, if you consider the motion along the vertical direction, again y is equal to y naught plus uy naught small t minus half a t square, because the body is going against the gravity. So minus half a t square, a is the acceleration, which is nothing but g in the present case. Again y naught is 0. Vertical direction distance at any time small t is given by y is equal to u naught sin theta minus half gt square. So remember that during the entire trajectory of the projectile, while going up and coming down, that's O to U and U to S, both times, the body is moving under the influence of constant acceleration due to gravity g, which is always acting downward, no other change in the direction of the acceleration. So the g term in all the equations should be used as a minus g, negative sign should be used. So at any time t, projectile, like at SA, its velocity in both directions are given by uxt is equal to u naught cos theta t, and uyt is equal to u naught sin theta minus gt. T is the any instant of time small. And if you want to calculate the velocity, linear momentum, maximum kinetic energies, etc., and the trajectory equation, this the path which it follows can be obtained as follows. So velocity at the maximum height position is given by ux is equal to u naught cos theta, because vertical direction there is no velocity. When it reaches the maximum height, it becomes 0. So ux, only x direction, horizontal direction velocity is which is same throughout the trajectory. So ux at the h max position, that is point u, is also u naught cos theta. And if you want to calculate the linear momentum, which is nothing but the mass into velocity, and the kinetic energy, which is maximum, that is half mv square at h max, at the maximum height point, are given by m u naught cos theta. M is the mass of the projectile body, so u naught cos theta is the velocity. So the linear momentum, which is mass into velocity, is given by m u naught cos theta. And the kinetic energy, which is maximum at the maximum height, is given by half m u naught cos theta whole square. The kinetic energy at the initial position, that is at point O origin, is half m u naught square. That is the velocity with which it is being projected. Hence, the maximum kinetic energy is cos square theta times of its initial kinetic energy. Find out what type of path the projectile is following during its entire motion. So the trajectory of projectile can be obtained from both coordinate equations. X is equal to u naught cos theta t at any time small t, and y is equal to u naught sin theta minus half g. Now eliminate t from the x coordinate equation, that is x is equal to u naught cos theta t. T is equal to x by u naught cos theta. Substitute that in the equation for y is equal to u naught sin theta into small t minus half gt square. So y becomes u naught sin theta into x by u naught cos theta minus half g into x by u naught cos theta whole square. T is replaced by, small t is replaced by x by u naught cos theta. So that gives y is equal to tan theta x minus half g into u naught cos theta square into x square. So which is in the form of y dx square, which is the equation for a parabola. So that the projectile follows a parabolic path with constants a is equal to tan theta and b is equal to half g u square u naught square cos square theta. The position of projectile at any time t in vertical direction is given by y is equal to u naught sin theta t minus half gt square. Now we are trying to find out the equations for time of flight and the time of ascent and time of descent. So y is equal to u naught sin theta minus half gt square at the capital T. So you will get, when you substitute y is equal to 0, u naught sin theta capital T is equal to half gt square. Hence, the time of flight equation is nothing but 2 u naught sin theta by g. And half of that will be the time of ascent, that is the time taken by the projectile to reach maximum height, and time of descent is the time taken by the body for reaching the ground from its maximum height. So by symmetry of the trajectory, both time of ascent and time of descent are equal, so it becomes half the time of flight, that is u naught sin theta by g. Both the time of ascent and the time of descent will be half the time of flight, that is t by 2, that is u naught sin theta by g, whereas time of flight is total duration of the trajectory of the motion is given by 2 u naught sin theta by g. Let us find out the equation for maximum height attained. So the distance travelled by the projectile in the vertical direction during the time of ascent, that is half the time of flight t by 2, is called the maximum height. So we have equation y is equal to u naught sin theta small t minus half gt square. T is any instant of time. In this case, t can be substituted as half the time t by 2, which is u naught sin theta by g. So, and y becomes h max. So h max, if you substitute the small t as u naught sin theta by g, and then you will get h max is equal to u naught square sin square theta by 2g. Similarly, range, because horizontal direction velocity is same, u naught cos theta. So the distance traveled in the horizontal direction during the time of flight t. So time x is equal to u naught cos theta into t. T can be substituted as the time of flight capital T, and velocity can be substituted u naught cos theta. So the range becomes u naught cos theta into capital T. Substitute capital T as 2 u naught sin theta by g. So you will get range is equal to u naught square sin 2 theta by g. In the h max you got sin square theta, here you got sin 2 theta by g, sin square theta. The range depends on the angle of projection theta and the initial velocity of projection. So for a given theta, it is directly proportional to the velocity of projections and its square. So condition for maximum range, how to get maximum range? So because for a given velocity, the range depends on theta, so sin theta can be equal to 1, that is the maximum value sin theta can have, so that r max becomes u naught square by g, becomes 90 degrees, or theta becomes 45 degrees. Hence, the range will be maximum when a body is projected at an angle of 45 degrees. And also you can note that the range will be same for two angles of projection, that is t theta and 90 minus theta, provided the body is projected with same velocity when 90 minus theta. This is because sin 2 theta term remains same for both theta and 90 minus theta, because sin 90 minus theta becomes cos theta, cos 90 minus theta becomes sin theta, hence sin 2 theta is equal to 2 sin theta cos theta is same as 2 sin 90 minus theta cos 90 minus theta, both will be same, hence the ranges are same for both things. So it may be noted that the range for angle of projection other than 45 degrees, either it is more than 45 or less than 45, the range will be less than that what we get for 45 degrees angle of projection. For angles of projection less than 45 degrees, the horizontal velocity component may be high, but the time of flight is less, so range will be small. Similarly, for the angles of projection more than 45 degrees, the horizontal velocity component may be less, but the time of flight is slightly long. Hence, both values of range in both cases will be less than that obtained for 45 degrees angles of projection. The time of flight and the maximum height terms both depend on the angle of projection theta and the velocity of projection. So the trajectories followed by a body for angles of projection theta and 90 minus theta will be different, though their ranges are same. He mentioned that the range will be same for angles of projection of theta and 90 minus theta. For a given theta and 90 minus theta, theta other than 45 degrees angles of projection, the H max, the maximum height obtained for theta less than 45 degrees, will be less than that for 90 minus theta angles of projection. Hence, the trajectories are different. That means maximum height attained are different, though the ranges are same for the cases of angles of projection theta and 90 minus theta. Already we have mentioned that the horizontal velocity component at any instant of time remains same. That is ux is equal to ux naught. At ux naught is the horizontal velocity component at the initial conditions. That is u naught cos theta. The vertical direction, it keeps changing uniformly, and also the angle of projection theta at the initial condition keeps changing to another value alpha with the horizontal at any time t as shown in the slide. This is because during ascent time, the projectile, the velocity decreases from its initial value u naught sin theta in the vertical direction to 0 at the maximum height position, and again it increases from when it is coming from dropping to ground from maximum height position. So during its ascent time, that means when it is rising from Q to S, O to S, the velocity ux decreases from 0 to Q, and initial value u naught sin theta at the ground. From the initial value u naught sin theta at the ground. So at any time t, uy is given by u naught sin theta minus gt, because g term is to be used with the negative sign, and you can see that this is a function of time t, whereas horizontal component u naught cos theta doesn't have the time term, hence it is independent of time. Square root of ux square plus uy square, which can be obtained as u naught square plus g square t square minus 2 u naught gt sin theta under square root. Since u is tangent to trajectory at any time, the angle alpha made by it with the velocity at any instant time t is given by the horizontal axis. The angle made by it with the horizontal axis can be given by tan alpha is equal to uy by ux. That is u naught sin theta minus gt, that is uy component, by u naught cos theta. So you will get tan theta minus gt by u naught cos theta. This is the angle made by the velocity component at any instant of time with the horizontal x-axis. So let us see the application of the points what we discussed so far in solving some numerical solutions. Now, if the horizontal range of a projectile is 4 to 3 times of its maximum height, then what is the angle of projection? So range is equal to u naught square sine 2 theta by g, and the height is equal to u naught square sine square theta by 2g. One is 2 theta, one is square theta. So it is given that range is equal to 4 root 3h. So if you substitute the given condition in the equations, respective equations, you will get tan theta is equal to 1 by root 3, or theta is equal to tan inverse 1 by root 3, that is 30 degrees. The angle of projection is 30 degrees. Now the horizontal, we can show that the maximum horizontal distance is 4 times the maximum height attained by the projectile. So we have equations for maximum range. R max is equal to u naught square by g, and h max is equal to u naught square by 4g, because sine square 45 degrees is 1 by 2. So you become h max becomes u naught square by 4g, that is r max by 4. So the maximum height attained is 1/4 of the maximum range covered, or the maximum range is 4 times the maximum height. Consider a projectile with the kinetic energy of 500 joules is fired for attaining maximum horizontal range. So then its kinetic energy at the highest point is given by as follows. For maximum range, theta is equal to 45 degrees, and velocity at the highest point is u naught cos 45. So initial kinetic energy is half mu naught square, that is 500 joules. So at the maximum height position, kinetic energy is equal to cos square theta times we told the initial kinetic energy. So cos square theta times of 500 joules, that is 250 joules. Now an object is thrown to a maximum height h. So what is the greatest distance it can? Once you say greatest or maximum, theta is 45 degrees inherently. So h max is equal to u naught square by 2g, r max is equal to u naught square by g. That is equal to twice the maximum height. So a person aims uh, at a bird through his gun from a point at a horizontal distance of, the bird is at a distance of 400 meters. So the speed given to the bullet is 500 meters per second for the bullet. Then he cannot aim directly the bird, so he has to aim at a certain height above the bird so that it will go and hit the bird exactly. So using g is equal to 10 meters per second, we can calculate range is equal to u naught square sine 2 theta by g, that is 100 meters. So sine 2 theta is equal to u naught is square. So angle of projection can be calculated as 7 degrees. 7 minutes, sorry, not degrees, 7 minutes. That is 7 by 60 and into pi by 180 radians. So the height above the bird is 100 times tan inverse 7 by 60 degrees. That is, you will get it 0.203 meters, 0.2 meters above the bird. He has to aim his gun so that it will go and hit the bird exactly. Now a ball is thrown from a point, the speed u naught at an angle of projection theta. From the same point, a person is running to catch the ball at a speed of, he is running at a speed of u naught half the velocity, so u naught by 2 to reach the ball. Then what is the angle of projection that allows the person to catch the ball? The person can catch the ball only if the speed of the person is equal to the horizontal component velocity of the ball. So that is only if u naught cos theta is equal to u naught by 2. So cos theta is equal to half, so theta is equal to 60 degrees. Now, a bullet is fired from a gun at an elevation of 45 degrees, that is condition for maximum range, with a muzzle velocity of 98 meters per second. And it was found to have a range of 900 meters. So, the possible range for 45 degrees of angle of projection is R max is equal to u naught square by g, that is 980 meters. But this is the actual range possible for the given angle of projection of 45 degrees, that is R max. But the achieved range is only 900 meters. 900 meters. So there is a decrease in the actual range possible. So the decrease in range is due to the air resistance. So the amount of range reduction due to air resistance is given by 980 minus 900, that is 80 meters. Now the height y and the horizontal distance of a projectile on a certain planet where there is no atmosphere, I mean there is no air resistance, etc., are given by x is equal to 60, t is the instant of time t meters, y is equal to 8t minus 5t square meters, where t is in seconds, the time term in seconds. Then the velocity components are given by, in the x direction, y direction are given by Vx is equal to rate of, because velocity is rate of change of displacement, so Vx is equal to dx by dt, that is d by dt of 60, that is 6 meters per second in the horizontal component, and in the vertical component dy by dt, that is d by dt of 8t minus 5t square, that is 8 minus 10t meters per second square. So initial conditions, that is time is equal to 0, Vx is equal to 6 meters per second, and v by naught is equal to 8 meters per second. So the actual velocity of projection can be obtained as v is equal to square root of vx naught square plus v naught square, that is 10 meters per second. And the angle of projection is tan inverse of vy by vx at the initial condition. So it is 53.1 degrees. Then downward acceleration due to gravity is obtained as ay is equal to dvy by dt, that is rate of change of velocity in the vertical direction. So vertical direction, that is downward acceleration, is given by ay y is equal to dy by dt, that is d by dt of 8 minus 10 that is 10 meters per second square. Now a gun is kept on the road aiming at hitting a car traveling along the same road away from the gun with a uniform speed of 72 kilometers per. The car is traveling at 72 kilometers per second. That is, you can convert this into meters per second into 5 by 18. The car is at a distance of 500 meters from the gun. The gun is fired for a maximum range condition, that is 45 degrees angle of projection with the horizontal. So, if the shell has to hit the car in t seconds, then the car travels in the t seconds is given by x is equal to 72 into 5 by 18, that is 201 meters. The time of flight is given by 2 u0 sin theta by g, that is u0 by g square root 2. Range of the shell is 500 meters. Already the distance is there from the gun to car, so 500 plus 20t, that you will get it as 500 plus 20 u0 by g square root 2. But the range, because the angle of projection is 45 degrees, the maximum range is u0 square by 9.8 g is equal to 500 plus 220 u0 by 9.8 square root. So solving those two, you will get the velocity of projection is 84.6 meters per second. Hence, the time at which it can hit the car is 12.4 seconds. That the range of the shell is obtained as u0 square by 9.8, that is 74.69 meters. Hope this finds useful to you. I see you in the next session.